Hi, I'm Dr. Ben Newman here, and I'm a coronavirologist with over 20 years' experience with these viruses. Next question comes in, this came in direct, so not through the Facebook group, and it's from Eric. And hello. Yeah. All right. And it's a two-parter, and they're actually both really good parts. Yeah. So, first part. Is there a way to find out if I gave a specimen, if that specimen was subject to variant testing? So, yeah, that's a fantastic question. All right. Let's tackle that one first. The short answer is no. But there's a good reason for that. And the reason would be privacy law. So it's not that it's impossible, it's that the rules are written in such a way that a responsible person sequencing your data would not have access to who you are, and there would not be a good way for anybody to trace that back. So, first of all, variant sequencing. It's a thing that takes about a month. It's not used for actual medical diagnosis because you can say, oh, you have the alpha variant or you have the delta variant, but beyond that, there's no difference in the treatment that would be given. So it's not medically useful to know which variant it is. It is epidemiologically useful because that tells us what is where and how much of it there is. This is the only way that we're able to figure out what's going on. So while most of those samples that become like variant sequences, most of these would come from positive sort of nose samples or saliva samples. And these are just samples that are done for a regular test. Some, but certainly not all, and not even most, not even many, of the places that are doing the tests would also have some kind of research group associated. And the research group would go through something called an institutional review board, which is in charge of making sure that any human subject's work is done to the highest ethical standards. And there's a whole lot of, it's not paperwork, it's almost all online, but there's a lot of regulatory framework, if you like, around that. So you have basically a lot of steps. And at each step, the idea is don't give out any more information than you have to. If you're doing something, it better either be for the direct benefit of the patient, or if it's not, if it's for like an epidemiology surveillance research sort of thing, there better be no way that you can actually trace that back to the person. So the person that's actually doing the variant calling is not the same person that's doing the actual test, and the systems are kept usually quite separate or with only like one person in the middle serving as a link between the kind of clinical side and the actual testing side. And so yeah, in practical terms, it should be theoretically possible if you were connected with the right person, but ethically and practically, no, it's not going to happen. So there you go. And it would also depend on where you're giving this. In some cases, it would be the state looking at the variant. It could be the country looking at the variant. It could be the WHO, potentially one of its branches or affiliates looking at the variant. It could be various universities doing this. And the procedure to call a variant is kind of expensive, and so this is not something that would routinely happen everywhere. Although you'd learn something scientific by doing that. And yeah, I would argue that it may actually be worth it. So, fine. That's the first half. Second half of this is so if I've had COVID and I've developed antibodies, would these antibodies be specific to the Delta variant? Given that I don't necessarily know what I got, but if you're getting infected around this time in history, I think the Delta variant was up. It's close to 60% of everything around the world. And remember, our knowledge of which variant you have is going to run about a month to 5 weeks behind reality. So that's how much time it takes on average between you spitting in a tube or having that Q-tip up your nose and actually somebody figuring out this is the variant and this is what you had. So I would say it's probably higher than that in the world, given that it's just been rising very steadily. If you ever want to check this for yourself, the best place to go is, for me anyway, this is where I get my information, nextstrain.org, nextstrain.org. And then if you go to that page at the top, it's got a global COVID analysis. And that's the one that I go to. And why not get your information from there? And then I tend to scroll down to the frequency graph. It's a big long rectangle with some lovely colors, looks kind of like a rainbow. And this is looking over time, so from the beginning of the outbreak until right now, and it's looking at basically the market share of each of these viruses, how much of each one existed at any particular time. And what you'll see is the delta is going like this at the end. It is rapidly pushing out all the other viruses. It wouldn't surprise me if this one essentially drives everything else to extinction. Except South Africa. It's not growing, but it seems to be holding its own. So South Africa variant holds serve, which one is that? I think that might be the Gamma variant. Yeah, if I've got that right. Yeah, everything else is struggling out there. Even Alpha, which was absolutely dominating things, is actually shrunk back down from about 50% to something like 20-25%. So yeah, see you later, Alpha. Yeah, nice knowing you. Or not. Anyway, actual question is, would my antibodies protect me against a variant that I may or may not have had? And the answer is probably yes. A lot of the antibodies that protect you against one variant would still protect you against another. And the other neat thing that has come out of the scientific literature recently is that your immune system is going to it holds on to a little bit of protein after an infection or after a vaccination. And it would appear that you continue to develop your antibodies. So an antibody, I mean, the way most people think of it, I think, is probably not quite right. It's a molecule that has a shape. And so just imagine a particular shape, some kind of cupped hand shape. And it has to be able to bind to the spike protein. And there are actually a lot of ways you can do that. For a baseball metaphor, if you happen to be from some part of the world where baseball is a thing, there are different ways you can grip the ball. There's like a knuckleball grip, and there's a split finger fastball grip, and whatever. You can just hold it, like a baseball or like an apple. And those all work just fine for picking up a baseball. And so there are different ways to make an antibody that can pick up a spike protein, because that's all an antibody is going to do. It sticks to the spike protein. And by sticking to it, it stops the spike from doing its job or makes it easier for the immune system to clean that up. So the neat thing is that your immune system is going to keep adjusting these antibodies. And all it's doing is sort of changing the shape. It's kind of experimenting with slightly different grips. It takes the ones that worked pretty well, and it will continue to modify those at random. And so even though you may have got vaccinated against or infected by one variant, there's a pretty good chance that you're going to have some specific antibodies that are actually going to be better against other variants than they would be against the variant that your immune system has actually seen. So I guess that's kind of nice, right? Yeah, the immune system, always full of surprises, and they're usually pretty good surprises. It's a pretty cool piece of equipment that comes preloaded on all of our operating systems. So there we go. I think that's about as far as I am confident answering this question right now. That's the current state of affairs. And there's definitely work to be done here. And yeah, it'll be interesting to see what we know about the answers to these questions in a few months' time. Yeah. So thanks very much. This has been Ask Dr. Ben.